Welcome back. We are going to do right triangle trigonometry. And some of these concepts you all have seen in geometry. And if not, this will be a review for some and a new lesson for others. So we're going to go over 6 trig functions that we use in trigonometry. They are sine, which is abbreviated SIN, cosine, COS, tangent, TAN, and then their reciprocal functions are cosecant, secant, and cotangent. So anytime they ask you to find the 6 trig functions, these are the 6 that we are referring to. Then, I don't know if you all remember from geometry, but the acronym SOHCAHTOA. And those actually refer to our 6 trig functions. S is sine, C is cosine, T is tangent. The O and the H, the A and the H, and the O and the A all refer to the right triangle. So everything that we do in this section is related to a right triangle. Then we have this angle, which we refer to as theta. And we're referring everything in terms of theta. So, for example, this is A, B, C. And then for the sides, this will be little a, because it's across from A, little b, and little c. So when they ask us to find the ratio of sine of theta, then that means that's O over H. That's opposite the opposite side over the hypotenuse, which would be little a over c. Then cosine theta would be the adjacent side over the hypotenuse again, which would be little b over c. And then tangent theta would be the opposite side over the adjacent side, which would be little a over little b. Now we're going to do the reciprocal functions. So it'll look like this. I'll just redraw this. Oops. A, B, C, little a, little b, little c. Here's theta. So we have cosecant, which will now be hypotenuse over opposite. And that's cosecant of theta. Secant of theta would be hypotenuse over adjacent. And then cotangent of theta would be adjacent over opposite. And then according to our theta on our diagram, cosecant of theta would be C over A, or little c over little a. Secant would be little c over little b. And cotangent would be little b over little a. So those are the ratios for the 6 trig functions that you will need to know. Now, anytime you have to evaluate trig functions, sometimes you are not going to have all 3 sides. But because this is a right triangle, we can find the missing side by using Pythagorean theorem. I'm writing this real big. And if you remember, Pythagorean theorem is a squared plus b squared equals c squared. So use this theorem if you don't have the lengths of all three sides. So for our first example, they want us to find the value of each of the 6 trig functions given this triangle. Here's theta. We got little a is 5, little b is 12, and we're missing c. So because we're missing one of the sides, we're going to use Pythagorean theorem. 12 squared plus 5 squared equals c squared. And it doesn't matter if you put the 12 before the 5. 144 plus 25. And then if you solve for c, when you get to this point, you want to square root both sides. And sometimes they'll come out really nicely like this one. Sometimes they won't, so you'll just leave it as a simplified radical. So now we have the missing sides. So to find all of the 6 trig functions, then you do this. Sine of theta. Oh, always write this. SOHCAHTOA. So, remember, sine is opposite. So look at theta. What side is opposite? 5. Over the hypotenuse, which is 13. Cosine theta. The ratio is AH. That's adjacent over the hypotenuse. And then tangent. That's opposite over the adjacent side, which is 12. Now, the good thing about this is when you find the first 3, finding their reciprocal functions would be a little bit easier because all you're doing is the reciprocals of what you just found. So this will be 13 over 5, 13 over 12, and 12 over 5. And there you have found all 6 trig functions. Now sometimes your missing side may not come out easily, and you're going to have to do what we call rationalize the denominator. And I'll show you how to do that. Now little a is 1, little c is 3, and little b we don't have. So you still use Pythagorean theorem, a squared plus b squared equals c squared. Notice I always put parentheses just to be on the safe side. So b squared equals 8. And when you square root this, 8 is not a perfect square, but we can break it down to square root of 4 times square root of 2. And the square root of 4 is 2, so that's 2 root 2. You always want to pick the largest perfect square when you're breaking it down. So now we have all 3 sides, and we can do our 6 trig functions. Don't forget, TOA. So we have sine, and I forgot to write theta. Remember the O and the H. That's 1 over 3. Cosine. That's AH. 2 root 2 over 3. So far, so good. And then tangent is O over A. Here's where we come to a denominator that is not rationalized. That means there's a radical in the denominator. So what you have to do is multiply the top and bottom by that same radical so you can get rid of it. So this will be root 2 over, well, you know, if you multiply a radical by itself, the radical goes away. So you have 2 times 2, which is 4. Then you do your reciprocal functions. So cosecant now would be 3. Secant Now we have to rationalize, so you multiply by itself. And there's that square root of 2 times square root of 2, which is just 2. So that'll be 3 root 2 over 4. And then cotangent. Now, instead of flipping this one, I would probably flip the original one to keep the radical out of the denominator. So this one right here would now be 2 root 2 over 1. But I never write the 1 in the denominator because it's understood. Okay, here's a checkpoint for you. And this will cover both examples 1 and 2. Here's theta. A, B, C. Little a is 1, C is 5. We don't have B. So I'll let you figure that one out. Okay. Here is our finished product where you can see all 6 trig functions. Well, first I had to find the missing side using Pythagorean theorem. And then I needed to have SOH, CA, TOA, so you can see the ratios of theta. So it's very important you look where theta is because that will determine your opposite, adjacent, and your hypotenuse. And then you notice with tangent and secant, I had to make sure the denominators were rationalized. And then cotangent, I did the reciprocal of the original fraction. Okay, the last thing we're going to cover in this first day of 5.2 are two special right triangles. The 45, 45, 90, and the 30, 60, 90 triangle. And with the 45, 45, 90 triangle is labeled like this: 1, 1, and the square root of 2. And then the 30, 60, 90 triangle, across from the 30 is always 1. Across from 60 is the square root of 3. And the hypotenuse is 2. Now, of course, on the 30, 60, 90, the 30 and the 60 could be in different places, but it's very important that you know that across from 30 is 1, across from 60 is square root of 3. So no matter where they are in your triangle, so even if it was like this, the 30 could be on top and the 60 right here. 2 is always the hypotenuse. This now will be square root of 3, and this will be 1. So, they ask you to find tangent. Oh, let me always do this. SOH, CA, TOA. And they wanted tangent of 30 degrees. You will look and do opposite over adjacent according to the 30. So you gotta look at the 30 and see what's opposite, which is 1 over adjacent, square root of 3. And of course, we have to rationalize it. And you know these two cancel out, so it's just 3. Okay. Then you could do cosecant of 45 degrees. So you'll look at the 45-degree triangle. Now remember, cosecant is the reciprocal of sine. So it'll be h over o. So the square root of 2. And guess what? It doesn't matter which 45 you use. Both of them have a 1 across from it. So that's the square root of 2. And then if they do something fancy, like give it to you in radians, we know from our unit circle that pi over 3 is 60 degrees. So you go to the 60 and you see cotangent. So you have to do the reciprocal of tangent, which is a over o for the 60 degree. A over O. And then you have to simplify or rationalize it. You see that? And what may help is if you put the reciprocal underneath. HO, HA, AO. And that is cosecant, secant, and cotangent. So that may help as well. And then if they get even fancier, they may ask you this. Tangent pi over 4 plus cosecant pi over 6. So from our unit circle, we know pi over 4 is 45 degrees. So if you look at tangent, opposite over adjacent, I like that one because it's just 1 over 1, which is 1. And then pi over 6 we know is 30 degrees. Cosecant, look, I already had it labeled. My reciprocal function is sine. So that's h over o for the cosecant. Pi over 6, which is the 30 degree. So h, your hypotenuse, is 2. And across from the 30 is 1. So we have 1 plus 2, and that answer is 3. And there you have day 1 of right triangle trigonometry.